Hello everyone, this is Ryan Pereira from Tagore Technology. I'm the Senior Apps and Marketing Manager here at Tagore. In this short video, we'll talk about GaN RF transistors that here at Tagore we'd like to showcase. This first page is just our contact info, so you can either contact me, based in North America, and I cover China too, and Steve Nugent, who covers all the other Asian countries and Europe. On this slide here, this is the first list of RFPAs that we have. Just going quickly down the list, we have a 5 watt, two 12.5 watt, and a 20 watt PA. The TA8210D and the 9210D are available right now, and the 5 watt and the 20 watt will be available next month in June 2020. We'll go into more details in the next few slides. Here now, this particular application note is kind of unique what we are doing, where it's a special application using our 12 watt 8210D GaN transistor and pairing it up with one of our switches, GaN switches. It's a 30 watt 4-throw switch, whereby we put both of them together on this app board as shown here and tune it for individual bands. This particular app node is focused for the multi-band LMR handheld radio that covers VHF, UHF, and 800 and 900 megahertz band. The nice thing about this is that we do all the matching on the demo board itself, and all the matching, majority of the matching is done at the output of the switch, where it is specifically tuned for the band of interest. There is some pre-matching done in between the PA and the switch, but that's very minimal. So this way you actually use a broadband PA, but narrow band it at the output of the switch, thereby giving you good harmonic suppression, which is quite important for this kind of application, and also maximizes efficiency too. A few plots here showing those different paths. So here is the 800 megahertz band. These two bands over here is the UHF band, where we actually broke it up into two bands. Our customers, for most applications, they like prefer to break up the UHF band to maximize again on efficiency. And this last plot here showcases the VHF band. So you basically can get 10 watt P out for VHF and UHF bands and 38 dBm P out for the 800 to 900 megahertz band, which is very typical for these types of handheld radios. The other beauty about this, also just going back to this previous slide, is you can really, because since it's a handheld radio, there's not a whole lot of space. So this also leads to a fairly compact design. And because we control the PA and the switch, we give everything to you all completely matched up. So it's quite beneficial too. This slide here shows our the other 12.5 watt transistor, the 9210D. Here for this application, you would want to consider the 9210D for broadband applications. So here, this transistor as compared to the 8210D is more broader. So here what we are showing is a 30 to 2600 megahertz match using one single. So this whole match circuit is with one single match. That's the beauty about one single match. You can actually cover this whole band. And we showcase the data here. We have actually broken it up into 3 plots just because we didn't want to clutter having too many plots on one graph. But basically you can see here it's 30 to 700, 800 to 1.6 gig, and then this last one 1.8 to 2.6. The datasheet is available on the website, so you can download it to get more info there too. But this is pretty neat in the sense that with one match, you can cover this whole band and get roughly 12.5 watt P out. most of the applications that we are seeing are for military style radios that need to cover this whole band. This slide here, again, showcasing again the 9210D, but this is for an application specific covering 1.8 to 2.7 gigahertz. This one here, we had done it for software-defined radios, and we have used an LTE signal to showcase the capability of this tune for this part. So here shows gain, efficiency versus P out, and the ACLR data on the bottom. This part, the TA9310D, is our 20 watt part, which is right now this is preliminary results, and we should have samples of this next month in July. This is again a broadband circuit that with one match covering this whole band, and it'll cover 500 to 2700 megahertz. We'll also have another circuit which we can talk about later at another time, where we'll extend that even further, covering the radar band. But here also with one single match, you can get 20 close to 20 watt. Right now this is not really 20 watt, but we're still making some optimizations to it. You would be able to get a little bit more power across the band, probably 20 watt more from 700 to 2700 megahertz. 500 meg, it might just fall a little bit shy. Also, this is at 28 volts. At 32 volts, you could get more power out of this circuit. Fairly decent efficiency, given that it can cover such a broadband application. And that's it. Those are the three main transistors I wanted to talk about. The 8 watt will also be available in July 2020. We do have data sheets available, S parameters, and obviously samples and demo boards. You can visit our website or give us a shout based on the contact info on the first page. Thank you and take care. Bye-bye.